In this kata, we want to convert a string into an integer. The strings simply represent the numbers in words. So 1 turns into 1, 20 into 20, 246 into 246, 783,919 turns into that same number there. The minimum number is 0 inclusively. The maximum number which must be supported is 1 million inclusively. The and in example given 124 is optional. In some cases it's present, in others it's not. All tested numbers is valid. You don't need to validate them. Okay. I'll tell you what, let's get started on it. And I don't promise we'll finish it. We may abandon it partway, but I think we can at least get started with some. This is another great candidate for test-driven development. So we ask ourselves, the link is in the chat in case you want it. You can grab it there. Great. What's our base case here?
1.
I think it's 0 actually. Right. It said 0 would be the minimum number is 0 inclusively. So 0 is our lowest number. And that would give us 0. And of course, next would come 1. And 1 would give us 1. So there's that. We can write our first test around that. Let's see what they have for us for tests so far. Here we have, okay. So what does it do? It converts a string of like spelled digits into a number, into an integer. Something like that. There's no, there's no scientific way to do a message like this. Keep it one line or shorter and try and cover everything that the problem is doing. Finally, if this becomes way too difficult to say, then oftentimes you want to break, we'll need some kind of new function. Now here we're going to do it handles numbers with 1 digit. We'll start there. And we will start, like I said, with 0. So this is just 0 would give us 0. Oops, like that. And I'm going to go ahead and delete these. And again, you see how I don't really think, I really try and discipline my brain not to think too far ahead. Like I'm not thinking like, oh my gosh, but then what about when it's 100,000 and 300 and da 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 da? And are there commas and are there this? It's like, I don't know. I'll get there when I get there. Right now, just got to turn a 0 to a 0 and a 1 to a 1. That I can do. So I come over here and I say something like, if, I'm going to turn this into str. If str equals 0, return 0. If str equals 1, return 1. Seems reasonable enough. So let's test it. Hey, look, we passed both of those. Okay, so of course, next would come the very obvious step of the rest of the numbers. So 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's all of them. And we'll do this part here, 2, 3, 4, 5, 6, 7, 8, and 9. All right. Now I could, of course, follow along and just do 8 more of these. Yeah, I could. That does not seem awesome though, does it? And it definitely doesn't seem like I'm gonna be able to go much further than that. So what if I make an object, something like const digits equals this, where I say 0 is 0 and 1 is 1. And then I change this to say return digits at string. And I go ahead and get rid of these. And I run it. Knowing, of course, I'm failing almost all of these tests, but I see that I start failing on 2. So that indicates to me that I'm still passing 0 and 1. If I want to be extra sure, I can just comment out all of these tests, keeping just 0 and 1, just to make sure that I'm still passing. Yeah, cool, still passing. Okay, so then how about I do that 1, 2, 3, 4 more times, and I have 2, 3, 4, 5, 6, 7, 8, and 9. Not none, but 9. And then 2, 3, 4, 5, 6, 7, 8, 9. Great. And let's bring all of those tests back. And retest it. Cool. All right, we've got all of our single digits done. We open up our test again. I'm going to write a new it block. And now we're going to move up a level and we're going to say it handles 2-digit numbers. And again, I just like really don't bother myself with whatever's coming too far down the road. Just focus on, hey, what's the next thing? I got all my single digits. Great. Now I've got 10 through 99. All right, we could even, if you want to put a note here, if that helps you, you can say we're looking at 10 through 99. Okay, so it seems like 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Seems like they're going to be just like these ones here, right? It's just one thing comes in, one thing goes out. We don't really split it. With something like 20, I mean, then we have to maybe think, maybe we can parse this a bit. Although, yeah, because like, how do I take 10 and split it into anything? I can't, right? 20.
I think 20 will work the same also.
Okay, and then how about 21?
That's different. 21.
21, you start to see like, oh, I should pull out 20 and then go back here with 1, right? Or 36. And we'll have to check if they have that as one word or 2 words, but we say, okay, yeah, 30 means something and 6 means something. But everything from 10 to 20 pretty much works just like these here. One thing comes in, one thing goes out. So let's do that now. 10 is 10. And these ones, I'm not going to do every single one. I'm just going to do a few of them. So I'll do something like 10, 16 is 16, and 20 is 20. Okay. Then I guess I just go over here and add to my object 10 more. Feels tedious, but it's the best thing that occurs to me right now. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20, 20, 19, 18, 17, 16, 15. Seems like I spelled that wrong, but I think that's right. 13, not 13. 14, 12, 12, and 11. All right, let's run it, see if we're still passing those tests. Okay, looks good. All right, back to the instructions. Let me see what it looks like when we have 19, sure. 46. Okay, so it looks like they're going to put our numbers together with a hyphen. That makes it nice and easy for us. So we're going to be able to just split on a hyphen here. So I'm just going to go slightly further and then we're going to go on to another problem. So here we say, all right, so then once I move on to, oops, not that. 21, I should get 20-1. And we should here get 21. All right, so let's see how we handle that. Come back to our problem here. And we say, all right, something like const digits equals string dot split on a dash.
Do
So
you also
for,
by space?
well, does 21 have do any of our numbers have spaces in it so far?
No.
So then we may have to take into account spaces in the future. We probably will, but with test-driven development, we just don't bother ourselves with that yet. None of our 2-digit numbers, as far as I can tell, are going to have spaces. See what I mean?
Yeah.
Cool. But I am sort of inferring there, right? I'm just guessing because they have 46 here with a dash and 83 with a dash, that all of our 2-digit numbers are going to come with a dash. It doesn't say that explicitly, but the 2 times that shows up in an example, we see that they have a dash. So that's what I'm going with here. I'm not ignorant of the fact that yes, there are spaces coming, but I see that spaces only happen once we get 3-digit numbers. See what I mean?
Yeah.
Okay, cool. And so because of that, I just don't worry about it yet. It's like, hey, that's a future problem that me in 5 minutes might have to deal with, but me right now doesn't have to be worried about. And me right now has to be worried about what do I do when I split these things up. So with our numbers until now, oh, I can't call this digits because I called this digits. Guess we'll call this something like digit lookup. And I'll rename that down here. Digit lookup, yep. And then this isn't going to be string anymore. This is going to be, we're going to pass in each number here. So how are we going to do this? We're going to have to refactor a little bit. Our string dot split for a regular thing, like for back to 1, is just going to be 1, right? If we start with 1 and it gets split here, ain't nothing to split. Therefore, it just is still 1, but now inside of an array. So I'm going to have to change that here. Otherwise, if I have something like 21 and I split it, I'm going to get an array with a string of 20 and an array with 1, like that. Now, 20, I've already handled right here, except for I've handled it like this. Interesting, we'll have to think about that. And 1 I've handled, but we have to make sure we don't end up with like 2, 0, 1. So let's take it a step at a time. First thing is, instead of just looking up 1 digit, I'm going to do something like, how about we say, let num equals 0. Then we'll write a loop for const digit of digits. So for every digit, num plus equals, you know what, let's make this a string. What about that? Num plus equals digit lookup, but not at string anymore. Now it's at digit. And then here we return num converted to a number. Interesting. Let's see if this would work for 1. So if the string 1 came in, we would split it, which would do really nothing to it except for put it inside of an array. Then we would have this string called num. Then we would say for 1 of digits, because it would be this string right here, num plus equals, go to digit lookup, find the digit 1, it would add a 1 here. So it should be like that. And then we convert that to a number. Yeah, that should still be right. This 121, I'm not sure, but let's see if this works for what we have so far. Let's open my tests. I'm going to comment out this last test. I'm still not sure I'm ready for this one, but I think the rest, although I've refactored quite a bit, I think they should pass. Yeah, they all still pass, which is great. I'm gonna bring this one back in and see if this one passes. Nope, failing. I got 2, 0, 1, and I expected to just get 2, 1. So, what if I
Did it include a zero because in two instead of 201 because it was it transformed the dash into a zero, like it translated it into that?
not so much. It took this string here, 20-1, and it turned it into this array, 20 and 1. And then it comes down here for each of these and it says, okay, so find 20. What is 20? Oh, it's 2, 0. Okay, so put a 2, 0 here.
Yeah, that's
And
what.
then, okay, and then find 1. So put a 1 here, and then that's how we get 2, 0, 1.
Yeah, I see that. Yep. Now I see that. Yeah.
Cool. Go ahead, DeAndre.
So what if you map through all of the digits that end in 0 and remove the second digit?
Like 20, 30, whatever, just remove it.
Yeah.
Okay, but what if we get just 20 in that case,
Oh yeah.
right? That we still need a 0 if we get 20 here. We could do something like change this to 2 and then times it by 10. And then this would have to become a number again. So if we said something like this is 0 and this is plus equals this times 10. So when 20 comes in, it says, okay, it finds 2, it times it by 10, 2 times 10 is 20, and then 1, but then 1 would have to be multiplied only by 1. 1 times 1 is 1, 20 plus that is 1. Seems okay. We could reverse it so that we had 1 first, and then we just have a multiple as we go. Let's try something like that. So hang with me here, I'll show you what I'm thinking. So first I'm going to say, let multiple equals 1. And when I split this, I'm also going to reverse it like so. And I'm going to say, find the digit, look it up, and multiply it by the multiple. But now this is a number. Yep. And now we don't need to convert this to a number. All right, let's walk through that. Let's go back to just 1 for a second. Okay, so 1 split is just 1, and reversed, it's still 1. We come down here, we have this number 0. We have a multiple of 1. Then we say, look up the digit 1. That's going to give us a 1. Multiply it by 1, and that will still give us 1. 1 is 1. Fine. See that I also need to change my multiple here. I want to say multiple times equals 10. Okay, then if I want to do 20, now mind you, I've changed 20 here to just be 2, like this. So if I want to do 20, 20 split is nothing, still 20. Reversed is the same, so we're just going to get 20. Oh man, I got a problem here though, because 20 still gives me this multiple of 1. Yeah, that won't work. Because it's going to just be times 1. It's going to be 2. No good. Don't know. Don't see it yet. Of course, we can do something like this, but that just won't do. We can't do this for every number. That is no way to live. That doesn't seem good. We could check the length. We say, hey, if the length is this, then go here. Otherwise, Anybody else got any ideas?
Maybe if the digit includes a dash, then you can map through and remove the second digit.
Yeah, that's a good idea. I like this idea. I was kind of thinking about this. It's like, okay, what if we treat 20 just like this, but we say, well, if there's a dash, then replace 20 with 2. Something like that. Like, what if we
We use
I don't know how
regular
to,
expressions?
sorry,
Can we use regular expression and match it?
we could. It'd be quite a complicated regular expression, I think. But yeah, we could. Tafari, go ahead.
Right, I kind of like, thank you. I kind of was like in DeAndre's idea, and it made me think of that. Okay, if you go through and the number includes a dash, the string version,
Mm-hmm.
instead of multiplying like 10 like you were doing, you could
Mhm.
divide it by 10. And then kind of sort of concatenate the next number onto it.
Got it. So like 20 would give us this, and then we divide by 10, which would give us 2.
Ooh, right. And then concatenate the other number, the other value to it.
Okay. So we can write this up in a way that makes some kind of sense. So we say something like, if string includes a dash,
Mhm.
then we're going to do one set of things. Otherwise, we're going to do what we had done before. And
Right.
so the dash things, while this is not very correct at this point, are like these things. Let me indent those things. Otherwise, we're going to return digits lookup at string. Let me see, digit lookup at string. Cool. So with this, let me just show you what I have here. This part is not yet correct. This part should be what we've done on our first bunch of tests. Let's go back to our tests and let's comment out this 21 for a second and then run our tests here. Okay, we see all green. That's very good. Now let's look at this block here and see if we can figure out our logic. So we said, if we split our string and then divide the first number by 10. So
Sort of like, because what I was thinking. Yeah, that's what I'm saying. Divide the first number by 10. Sort of like what we're doing is, what do we call it? We're handling it like in base 10. Because that's
right.
So if there's some way for us to do it, yeah, along those lines. Sorry.
Okay, yeah, that sounds good. So how about we write a regular for loop for let I equal 0, I is less than digits dot length, I plus plus, and then we will say number plus equals digit lookup digit, like so, and then if I equals 0, num divided by equals 10. Yeah, seems feasible. And then return num, get rid of this. So 20 comes in first, I is equal to 0, digit lookup digit, that will give us 20. Then if I is 0, which it is in this case, the number divided equals to 10, which will give us 2. Oh, but now we're back to this other problem. No, here what? I don't think we need to do that now. 20, no. How about this? I don't think we need this. I think we can just do, it is plus equals 20 and then plus equals 1. Yeah, that works fine. Let me bring that test back. I think it works now. Nope, digit is not defined. right here. That's because it's digits at I now. Although even that I can probably redo the way it was. Cool, there we go. So that works for 21. Let me rewrite this back to what it was. And that was for const digit of digits. And here then we can just write digit. Try that again. Yep, missing a curly brace right here. Cool. All right, with this, we're going to need all the other. Ooh, let's make sure that's not what was saving us, right? That would be the worst. Okay, we're gonna need 30, 30, 40, 40. Let me copy a bunch of these because it's gonna be faster than me. 40, 50, 60, 70, 80, 90. Good. 90, 80, 70, 60, 50, 40, 30, 20. Okay. Now we'll take this here and we'll write some more tests. All right, there we go. Okay, we'll say here 25, should give us 25. 52 should give us 52. And 97 should give us 97. Oh, beautiful. Okay, so I feel like we're pretty confident then that we're passing all of our 2-digit numbers. Okay, so I'll stop here. It's a great problem. We're starting to see a pretty good pattern here. Probably from here now, we can think like, okay, so now I'm going to do 100. I'm sorry. Yeah, though, that seems fine. Is it going to be 100 though?
The 3 digits will be different.
It will be different.
Yeah,
One,
we did
101.
include a space.
783.
That's 6 digits.
1,919, 246. So if we now break on spaces and then find a digit here, multiply it by 100, and then this we've already handled. Don't know. I'll leave it to you guys. Can work on this one. 4s are always nice and challenging. And I would say, I will say this anytime, like, oh, so many new messages in the chat. Okay, 15 is spelled incorrectly. That's still true. We don't want that. Thank you. Yes, it is. 15 there. Thanks for that. Okay, so you'll notice on CodeTrack, I don't think it ever goes past 5s. And the reason I put that is not because I don't think 4s are great. I think they are. I think they can be very interesting. I think you can really grow from them. But mostly because you're so unlikely to get this kind of problem in an interview, because anyone would say, yeah, this problem takes a while. And people just don't have that much time to do this in an interview, to like watch you do this for an hour and a half or so, whatever it's going to take. It might take longer than that. So while I will not, just like the last problem, there's no such thing as a bad problem to do. There's learning available in every problem, but you just want to make sure that you are like tearing through 6s especially, but 6s and 5s really smoothly in 45 minutes or less, maybe with a 45 minutes to an hour tops. That is where you're going to really get the best return on the time you're spending learning to code and practicing on problems like CodeWars. And it's why I pick, especially in the intermediate section on CodeTrack, when you go to CodeTrack and you go to your problems here, this intermediate tab, to me, this is just gold. Whenever I'm sort of talking to someone, I'm always looking at what they've done in this section here, because if you can pass most of these problems in 40 minutes or less, then you're pretty darn likely to do well in an interview. Anyways, I don't want to discourage anyone from taking on harder problems. That's certainly not my goal here, but I just want you to know that when you take on a problem like this, very interesting, very helpful in pushing you forward as a developer, not that close to what you'll get in an interview. You might get a smaller subset of this problem in an interview, but not this whole